Okay, we're recording now. Hi, Amin. It's a real pleasure to have you here. Welcome everyone to our webinar. Go ahead, Amin.
Hey, yeah, thank you very much for inviting me.
Yeah, so welcome everyone to Virtual AI's webinar on jailbreaking LLMs and agentic systems. I'm Sanmi Koyejo. I'm one of the co-founders of Virtual AI. And speaker today is Amin Karbasi, who's Senior Director of AI Research at Cisco. And known Amin for a long time. I think we were academics together through various places, through careers. We've spent some time together at Google. So really excited to talk to you today. I think also some of the premise for this conversation came from this really cool tutorial that you ran at ICML, and I'm looking forward to diving a little bit into some of what you shared about jailbreaking and some of those details. Before I get started, I'll just do a 2-second promo for Virtual AI just to kick things off. For those who are joining, and if you're not familiar, so Virtual AI provides AI security and compliance suites around red teaming, guardrailing, and agents. We do this in using technology that allows you to provide visibility via the red teaming and observability, guardrails, which we'll talk quite a bit about today, that are multimodal, multilingual, can handle things like text, image, audio, video, and code, and then agents that take some of this technology that we've built and deploys it for agentic systems and the emerging agentic landscape. So looking forward to the conversation today. I think today the plan is to talk through a lot of, I think, what's emerging in understanding where jailbreaks live in the ecosystem, starting off with, you know, standard language models going all the way to agent systems. I think we're learning so much, and I think your work is a lot of what's leading this direction, understanding how to think about these questions. I want to start off with maybe if you want to say a couple of minutes to introduce yourself and say a bit about why you think this is an important set of questions to be engaging in now. And in this context, I'm thinking of some of your early in the context of jailbreaking. Some of your work, for instance, where you worked on trio of attacks that showed some new ways to jailbreak at the time GPT-4, and you showed all the way up to 98% success rate in jailbreaking. And I imagine, actually, I'm curious that some of those successes will still work in even more advanced AI systems. At the same time,
Right.
lots of large corporations, say IBM, has reported some like 13% of organizations are experiencing AI breaches costing, several millions of dollars. What's your sense of why this conversation is important, what's important now, to what extent enterprises are prepared for what's coming and engaging in, and this question of
Right.
jailbreak security and AI ecosystem?
Yeah. Yeah. Okay. A lot is packed into your questions. So let me first start out with saying that everything that I'm going to say today, don't take it with a grain of salt. Take it with a boulder of salt, right? So it's a very fast evolving field, and many things that I say are my best efforts to understand the landscape, and are not necessarily correct. They might be correct today, might be incorrect tomorrow. So that's the first thing that I want to say. The second thing is that these are really my personal understanding, and of course, it's not Cisco's official standing on these matters, right? So it is really a scholar thinking about these problems, right? And understanding that. Um, and the third is that all of us, Sanmi, me, Bo, everyone in this space, um, we have some knowledge, but it is super limited, right? And so with that comes, all sorts of like, you have to have basically apply Bayesian optimization with about what I'm saying, and then, what is the best action you have to take. Okay, so these are like the three things that I wanted to say first before answering your questions. So I think the first question was about tree of attacks that really started off my journey into the vulnerability. I think before that, I have been working mostly theoretical, I think, and about optimization and even like poisoning, targeted poisoning attacks, but really about classical problems like classification, regression, right? And for those problems, the nice thing was that because there has been such a long history of research, it was much easier to say things rigorously and come up with attacks and defenses. All right. So, but I think this haven of theory left us, with LLMs. Um, so when I started looking vulnerabilities of LLMs and the question that I wanted to answer and at the time in collaboration with Robust Intelligence was whether we can come up with an automated method that jailbreaks, right? So no human in the loop. Is it possible to actually do anything that with very high success rate basically jailbreaks LLMs? And so because my background was all in optimization and those kind of things, we also looked at this problem as an optimization problem. So what we were trying to optimize was like the input to LLM. Is it possible to optimize that input so that the output is exactly what we want, right? How to wire a car, how to make a bomb, or so on and so forth. And the tree of attack was basically an offspring of that line of thought. Um, So it is interesting that I think, if you look at it, it's a very, very simple attack, right? The attack is basically, okay, you use two other large language models, right? One as an attacker, which is usually much smaller than, the target, like GPT-4 that you were talking, or, Google models, etc. And then there is a verifier or evaluator that just looks at the input and output and says, was it successful or not, gives the feedback to the attacker, right? The simplest control system you can ever think of. And that was it. That was like, so that was the nucleus of the attack. And the way that the tree of attack realizes is that, it takes that nucleus and then starts from a root and goes into different directions, explore different, prompt space in order to find the vulnerability, right? And so that is what it is. And it turns out that is a very universal way to attack models. It is still like I think one of the standard ways of stress testing LLMs, and I think in industry people use it in order to stress test models, like to understand whether it is vulnerable or not. It is funny that it still works.
Indeed.
Not as good, but it's still like I think quite well.
Yeah, no, all this tracks to me, I think, resonates. Both the fact that the problem has such staying power, but also that, some of the attacks we haven't fully protected against,
Yes.
even as the capabilities of the systems have been increasing
Yes.
so quickly. So,
Yes.
so along these lines, you with a couple of others worked on a tutorial at a recent conference, the ICML conference, International Conference on Machine Learning a few months ago, that was engaging in this question more broadly. And so, you showed the evolution from LLMs to full autonomy. You showed research around automated attacks. And I think something that's interesting for us, given I think some of the work both of us do, is thinking about how automated attacks often outperform human red teamers by a good amount.
Yes.
What's your sense on to what extent the traditional cybersecurity playbook still holds for AI systems? To what extent aspects of this, might be broken or at least insufficient for the evolving landscape of AI security, AI red team?
Right. So I'm going to so maybe so my first answer is a tautology. Okay, so and here's what it is. I think anything that can be automated will be automated by AI. Okay. So that is, I think it will, that is basically the evolution that we are seeing. And that includes, I think, that includes red teaming. And red teaming of, I think LLMs, um, it can become automated and probably, and to some extent it has become automated, even though there are still like humans trying to find new ways to jailbreak. But I want to click on the um, on on the previous point that I made about like search problems. I think some of the problems that we see in this space are really search problems, and this is why what AI and general computer science is good at. So if you want to solve a search problem, I think it is you have to find an algorithmic way to do it, and then it's going to be automated. Um, so in terms of like, cybersecurity, whether it is obsolete, insufficient, etc., I think the real shift that I see that is happening, again, based on my very limited knowledge, is that what used to be the case was a very static landscape. You had a vulnerability, you patch it, and it is fixed. With AI, what has changed is that the landscape is very dynamic suddenly. So in one context, something might be safe. In another context, it might be very, very dangerous. And that is why, previous method, you cannot just simply patch things. You have to continuously monitor, and you have to continuously try to protect the system against. So I think that is like the shift that we are seeing, and that is, I think, what the field is going. And when you're in a very dynamic system, I think you have to find a way that humans and autonomous systems work together.
Yeah, no, this tech, I think completely makes sense. I think you alluded to some things I wanted to maybe deep dive a little bit on. So you're talking about thinking about the problem as a search problem. I think done stuff like TAP methodology, done work. I've done some work on things like best event attacks,
Yes.
and you can show that you can get high success with very low cost for the attacker
Yes.
against often state-of-the-art system.
Yes.
I
Yes.
wonder if you could spend a few minutes walking us through, from an attacker perspective for now, how these automated techniques actually work. What makes them so effective? What makes them also so cheap for the attacker to
Yes.
implement and deploy compared
Yeah.
to state defense?
Yes. Very good. So the way that I think many of these attacks, let's just talk about the one LLM, not even agentic systems. So the way that there are, um, I think there are maybe two general ways of like attacking such systems, and one way is in the token space. Okay, so and these are the early waves of attacks where you wanted to, you are giving a questionable prompt, right? How to wire a car. And then what you were trying to do is that, you want to append some tokens to that prompt such that the LLM starts with sure, here how it is done, right? It starts with very few tokens at the output. You want to maximize that. And then what people realize that once the model starts with that sure, it is going to continue. The models try to be consistent and they are going to continue. And that is, I think, what people really refer to as shallow alignment. The model cannot correct itself. When it starts in that train of thought, it is going to complete itself and it's going to give, this kind of. So then if that is the case, one way is to find this few tokens at the end, append at the end so that you can actually get to that response. So that's a search problem. And that you can actually, people have shown that you can, again, look at that as, a continuous optimization problem or a proxy for a continuous optimization problem and basically maximize the likelihood. So that is one set of attacks. The other set of attacks that, pair, tap, and adversarial reasoning, our newest, work and basically is based on, is that now instead of doing this, you work in the prompt space. So you basically try to make a scenario for the model such that in that scenario, the model answers affirmatively to the question that you want, right? And so it starts with a very with maybe even with the prompt itself, like the prompt that the language model is going to not answer to, and then changes the scenarios and see how the model behaves and picks up on slight changes in the answers and deep and dive deep into that direction, right? So tree of attack basically starts with one thing and then it goes to two things and then it goes to four things and then it goes to eight. Of course, this, if you do just this naive thing, then it's going to explode. That is why you have to also prune, which is another very, very, very heuristic technique that people have used over and over, is that, some directions you prune them early, some directions you continue, right? And that is basically tap is, tree of attack with pruning. That is a pruning part, and then that is how it has become very effective. Now you can double click on tab and you can say that, well, that seems very much like reasoning, except you're not going back. So if you add that component, that you know what, I'm going down this, but it doesn't seem like a correct path. Let me go back, take another path, or let me pick up that signal. Once you add this thing, then it becomes super powerful, right? So that is basically the adversarial reasoning method that basically jailbreaks all the reasoning methods now.
So you're really exploiting the coherence bias and then
Yes,
sort of reasoning, both of which you need for the capability part of the system.
yes,
So
yes.
it's exploiting the capability for
Yep.
this robustness question. I think one of the things that has also maybe changed in the ecosystem is move from some of the single turn style attacks.
Mm-hmm.
I think some of this is reflected in your work to the multi-turn. I'm
Yes.
curious how you think these questions on the attack side evolve, and maybe we allude a bit on we'll come to measurement in a little bit, but I'm thinking, once you go from that to multi-turn, do the methods fundamentally change? And I'd be curious what the most interesting real-world attack you've seen against an enterprise so far. So
The
something to
most
validate some
interesting
of how you
one,
think about
yes, which is not my work, right? The most interesting one that I've seen is what is called the decomposition attack. And the idea is super simple, and I don't think there is any defense against it. And the idea is actually very natural. You ask question, so you have a big hidden question in mind, and you break it down into very benign questions, right? So you want to rob a bank, but you're not going to ask that question. You're going to ask very, very simple questions that if you put them together, you know how to rob a bank. And that is actually how, to wire a card. That is how I think, one of the incidents was actually using exactly this decomposition attack, like, basically prompting the model with benign questions about, uh, you know, usually where are the cameras in the banks? And then, the model is going to answer about, where is the teller in the bank? And then, give me, all the questions that the model knows and it doesn't have any suspicion that, why it shouldn't give you the answer. Put them together, then you have your answer. And this is basically multi-turn in one sense. And it is also like your hidden intent is not revealed to the model, right? The model doesn't know why you're asking this question. It doesn't have any. So that is like something that feels very hard to actually protect against.
Yeah, Yes, I think these attacks, we'll talk about defenses in a little bit, but
Right.
yes, the attacks get sophisticated very quickly. And this insecurity is always shows up, right? This back and forth between the attackers and the defenders. And so we'll talk a bit about this.
Yeah.
Maybe before that, though, I'm curious on the measurement side. So maybe a couple of questions.
Yeah.
And what, in your sense, just looking at the attacks and framing it around red teaming and security, what should enterprises be looking at in terms of measuring the risk surface? What metrics matter the most? I think this is evolving quickly, so intentionally a hard question, but curious what you've seen matter. Attack success rate shows up, but that's against a certain pool. Like maybe any attack is complete failure, and so you drop everything. Like, what's your sense of what good measurement practice is for enterprises?
So I think for the enterprise, it is really about the utility. And my sense is that, like, attack success rate, maybe it is not something important to them. Like how whether the model is going to answer these questions or not is not something that they really worry about. I think what they really worry about, based on these things, is that, okay, now they have sensitive data, or there is a breach. How much this breach is going to cost them? Okay, so it is really a risk utility trade-off for them. And I think that is what they really care about. At the moment, my sense at the moment is that it's not high enough. They're all worried. They all try to protect. It's not high enough that they say do not use these methods,
Yeah,
right? But
this
at some point, right, it's going to be high.
could I reflect this back as well? I think what I'm hearing is purely on, can I successfully attack a model? I think that resurface is well exposed, and there's a lot of things to say there. But tying this to real world costs,
Yes. Yeah.
financial or otherwise,
Yes.
I think that link is still like, there's some examples, some of these are high profile,
Yes.
but you're hearing it's not always salient enough for decision makers to anchor on what part of this, like how they should factor this into the trade-off for decision making.
Right. So my sense for now, again, this is very limited knowledge that I have, is that so it is the reward of using these models so much outweighs the risk now that the enterprise, or the financial entities and all that, they still want to use. Um, and however, I think they're aware of the risk and they want to protect themselves. Okay, so that is why I think they're also at the same time they're looking for protections, at least like some layers of protections. Um, but um, but but boosting performance using these models might outweigh completely the risk at the moment. So I have not seen many examples of like companies saying that you cannot use, right? I remember that in Connecticut, when I used to be a professor, there was actually a law, I think by the government that you cannot use AI in for government work. So that was the extreme example that I have seen. Um, but in general, I don't think that is like that is still the case. There are exceptions, particularly regarding Chinese models. So I think in many entities, you're not allowed to run them inside the infrastructures because they're very worried about backdoor attacks and they don't know what is in the data, even though we don't know what is in the data that Llama trained on, but they're way more suspicious regarding Chinese models and running them inside infrastructure. So there are very, very tight regulations at Cisco about this, and I think many other companies.
Yeah, I want to come back in a minute. I'll come back to some of the defenses and trade-offs in decision making. But one more thing on the evaluation bit. I think another thing that your work has alluded to is this trade-off between risk from human attackers versus risk from automated attackers. And I'm curious, for folks who are thinking about evaluation of measurements, like, is it clear to you, some of what my framing on this is, I think the field on the attack side and red teaming side, particularly for classic security, was much more about human red teamers and human attackers and human expertise guiding all this. I do think in terms of risk surface, it's moved quite a bit to the algorithmic side. But I'm curious on your sense on what this means for people, and maybe thinking about this trade-off, right? And thinking about measuring risk. How do you think about the risk from human creativity and coming up with attacks versus algorithmic scale and algorithmic, like, I guess the worst version is the combination, and we do work on thinking about a combination of both of those. But I'm curious on how you think about the trade-offs between the automated side, the human side. What would you be most worried about for those two dimensions of risk?
So my sense at the moment, I think, even all the attacks that we said, like, that are automated, there was a human component in them that has been using AI and automated method. We put them on a steroid. Like, storytelling is a way that people actually use in order to fool LLMs. We just put it on a steroid, right? So I think that is what is happening. Like, a human comes with a very interesting idea, and then you automate that, and it becomes like, you can basically give it exponential growth.
Right. So this is, I mean, I guess this version of this is on the algorithmic side, where humans, like your earlier tree of attacks work, which is, I mean, it's exploiting human intuition, but really it's research creativity more than anything else.
Yeah.
And I guess there's also versions like what you just talked about, where it's exploiting how we think about humans having conversations and what works to convince people. And that's where the creativity comes from. But really, maybe the real world would be a mix of all these things, or is a mix of all these things already.
It is already a mix of these things. That is correct. And yeah. And from the attack side, and we have to also understand that the attacker has to be successful only once, right? The defenders should be successful almost all the time.
So this is a good, indeed. I think this is the real challenge, and also to pivot on some, or at least anchor on some of your earlier comments around decision makers and risk. My sense is we are getting trickles of like public, either financially costly or like reputational costly,
right. Yes.
jailbreak issues and other kinds of so for the decision makers, do I wait till my company is on the news or we've lost a couple $1 million, or do I put something in place now while I'm thinking about this question? But I'm curious on your stance on defenses more generally. I think you started to talk about this. In many ways, the defense job is much harder.
It is
Than the attacker job.
Yeah. Breaking things is much easier, as I learned from my kids.
Indeed. Yeah. So yeah. What are your thoughts on maybe on the research side, but also some of this is our work on both our sides is thinking about how this translates to enterprise. And what's your sense of the frontier on the defense side? You've talked about the Swiss cheese model, which I think is such a fascinating analogy. Curious if you could expand on this model and say your thoughts on where you think defenses are going.
Yes. To double click on your earlier questions, I think policymakers should really think about putting things in place now. It will be too late, like when things break, and they're completely loose. And so this is like such an important problem that there should be a lot of because I think I think the vulnerability surface is just expanding exponentially. Okay, so and with any exponential growth, usually what happens is that there are all these if you look at a stadium that is like there is 1% and then there are two and then there are four and like until it is full. If you look at time, almost all the time the stadium is not full. It is only in the very last few seconds, right, when you double it, right? And that is exactly the attack. That is what these attackers are doing, right? So Okay, it's not full yet, but it is like you see that it is growing exponentially, right? So it will be too late to just wait until the whole system is completely exploited. So to your earlier question, I think it is wise for almost all companies to think about them and put some system in place. Now, in general, I think the way I think about defenses is that, and it comes from the COVID era, and that so there is some problem, and there is not one perfect solution. Okay, and but if you put many imperfect solutions stacked together, you get a very good system. So that is the analogy that comes from, right? And that is the way that, starting to think about this strategically, we basically converge to like, okay, so that is probably what we want to communicate to the community, is that like, we should not just zoom in and put all of our eggs in one basket. We have to have like different methods and then stack them together. And then at that point, we might actually have a system that works or defends, good. So what is the first layer of this Swiss cheese? Probably the first layer is all the alignment that, all the frontier models are trying to do, right? So they put actually millions of dollars into like aligning the models with, with human values and making sure that the models behave correctly. So that is where it is. But then, actually, both of our research and many other people's research show that this is not sufficient, right? So alignment is probably it's very, very insufficient, right? So you can still jailbreak. I mean, it's amusing to see that still today you can jailbreak. There are methods that jailbreak frontier models to close to 100%,
Right.
right? So clearly alignment is not, sufficient. Alignment is good for a benign user. A user that is like really using AI for, boosting performance, they're not really malicious. They're not trying to use. All right. Now, um, and then so that is the first layer. Now the other layers actually come right after. For instance, um, as we do the attacks in the prompt space, maybe we also do the defenses in the prompt space, right? So that is one thing to do, right? So you change the you're not going to just directly input the prompt to the model. You're going to slightly add noise to it, make it smooth, and then the model is going to probably behave better. So that's one line of attack. It works for some methods, it doesn't work for other methods, right? Again, it's imperfect, but it is better than nothing. Another thing is, for instance, that is what OpenAI did. I think the core idea is very interesting. Is like, okay, so there is a prompt, you should reason about the prompt. If you have a reason model, it can reason about the prompt, right? And then check whether it is going to be contradict some of the policies they have in place, right? And they showed that they could effectively do that, even though for the type of attacks that the model has never seen before. It could correctly reason that this contradicts the policy, therefore I'm not going to answer. It's not sufficient again because what they didn't think about was the adversary can also do this. It can reason about the reasoning and then break it. All right, so better than nothing, but not sufficient. Another layer might be also what you guys and also what we did is like put something around the model, and which is what we call guardrails and AI firewalls. Look at the input output or the input and classify the whether this is, or at least flag, is this something that good or not. So you put different layers, and then hopefully you're going to catch most of the misbehaviors or malicious users. We to advertise, we just put a blog post about like how we can use Llama itself in order to protect Llama, right? It is a very simple observations about how you can use the internal embeddings of the model, right? And then basically use that as a guardrail. It works then much better than Purple Llama and what Llama actually is, which is fascinating.
Yeah, it is interesting. So I guess it's just using the technology, but in a different way.
In a different way. Yes.
Yeah. That's great. Yeah, no, I think there's a lot of surface here, and we're doing a lot of work, as you've alluded to, on parts of the ecosystem. I think particularly on how effective we can make guardrails. I think we could spend easily the whole time
Yes.
about guardrails. I think
Yes.
it's a fascinating topic. We've invested
Yes.
quite a bit, both in performance, but also specifically in things like latency and speed, multimodal attacks, which a whole other risk surface, and ways that you can combine across modes. We talked a bit about multi-turn, but instead, maybe I'll shift a little bit to the agent world, which I think
Yes.
is a fascinating and quickly evolving part of the ecosystem. As you know, a lot
Yes.
of the excitement in the field is moving from standalone generative AI systems to systems that can take actions. I think, for example, many organizations, but for example, OWASP released the Agentic threat categories, issues like memory poisoning, tool misuse. I'm curious on your sense of what fundamentally changes about some of what we've talked about today. So the attack, the measurement, the defense side, when you're going from static, say, language and other kinds of generative AI models to now agent systems that have this ability to take actions. What changes in the risk surface? What changes in how you think about attacks, defenses, measurements, and the rest of the ecosystem?
Yes. So I think this is I think there is no surprise that we are going to towards these agentic systems are going to be much more powerful in general. So I don't think that there is any question about that. What is very challenging in the agentic system is that I think when you have one LLM, what you're trying to do is to protect against words. In agentic system, you're trying to protect against actions. So suddenly, the thing that you're trying to protect against changes completely, right? So in the simple word of one LLM, it's all about information. You're trying to make sure that the information doesn't leak, or the misinformation doesn't go out, or the information that you don't want the model to output will be output. When you go to the agentic system, then suddenly you're not too much worried about that. You're worried about this whole ecosystem is going to act in a very malicious way. And that becomes I think, a much, much bigger problem, right? So, we both have, I think, control theory background, or we know about control theory. And for a non-stable system, it doesn't take much in the input to have like an explosion,
Right.
right?
Okay.
And that is exactly what is happening, I think. You can have very small vulnerabilities in small set of agents that is going to have a huge effect on the whole system, right? And that is, I think, the main issue. That is what keeps me at night.
Okay. A point well taken. I think for many of us, keeps us up at night too. So maybe on the other side of this, for enterprises who are, also being kept up at night with these kinds of issues, what might be, if you had to suggest a thing to do tomorrow as a first step to have a better stance than what they might have now? Like, what would be your first suggestion for enterprises who, just want to have better AI security?
So, right, that's I think there are two aspects to this. One is like a human aspect. The reason that we are, a lot of people they want to use AI because it is going to boost their performance. So the enterprise, from the enterprise side, they should provide safer options, right? If the only thing that you have access to is DeepSeek, well, they are going to use DeepSeek. So you have to have like very safe options for the people to actually use, all right, in your company. The second is the second aspect of the human part is that you also have to teach people how to use this. For instance, if you have very sensible data about customers, it's not a good idea to share it with third parties. Right? So those kind of things, we need education. Many people willing to when they understand, oh, this is actually the problem. The data actually leaves our infrastructure, it goes somewhere else. It must show up in something else. That's an issue, so we should probably not do it. Okay, and I think there are solutions around this, right? On the other side, there are going to be all these bad actors, and I think the endpoints should be very well monitored. And that's the first thing that I think they should do. They should monitor the endpoints. They should understand whether users are going to use shadow AI and detect them. I think a lot of problem goes away if you do that.
This is great. I think also great advice for folks who are thinking about building, deploying. I think once we start sharing some of these, the webinar conversation out, I think some of these will be quite salient for many enterprises who are thinking about deployment. Maybe I would not normally ask this question, but selfishly, since we both spend time in academia, I'm curious on the gap, academic work and sort of enterprise work separates in certain ways. I think some of this ties to what's most urgent in terms of real world deployment. Some of this ties to questions that are most interesting academically. I'm curious if, maybe you do, but, if you had some chunk of money to invest, or you were going to advise academics to do certain things, or I don't know, you're talking to industry partners who are thinking about work that supports some of the real world deployment questions, some of what you're seeing. I'm curious what you think most immediately would be interesting for joint collaboration, or at least seeding some of the questions that you think are open that are not sufficiently engaged with or addressed.
Yeah. So to me, and we actually got a lot of interns now, and so at least this is one way to engage with academia, is that I think there are a lot of interesting algorithmic questions from the attack and the defense side, where you really need someone to better understand what is happening, for which you may not have the bandwidth to do it yourself. So almost all these attacks and defenses that we came up with, there is usually a student behind, right? So the tap attack was my own student. The adversarial is another student, right? Um, uh, and the defense is, yet another of my student at Yale, like working like they just, interesting observations that you do not need a lot of compute to make, right? Um, Actually, that is the fascinating side, is that some of these things actually don't need much compute. And you can still do them, and they have an effect that is beyond your, the budget that you use. So that is how I feel about the collaboration. It is like there is a very concrete problem that we want to better understand, and it doesn't need too much compute. These are very well suited for academia, and they usually have again an exponential effect if successful. I'm aware of like the computational gap. Some of the things you cannot actually do, right? Where in academic circumstances, and so it's one of the reasons that I'm pursuing, I'm changing a lot of my attention into industry, because this is where the systems are currently being built. And so if the system is being built here, probably it should be close to that system.
Yeah, this is great. Thank you. I mean, I think this has been a really fascinating conversation. Covered a lot of ground, all the way from some of your tutorial work, some of your previous work on attacks, industry relevance, things about defenses, agents. I think we covered most of what we can cover in a very short amount of time, but I think each one of these threads could be full conversation.
Yes.
But really appreciate your time today, and just a fascinating conversation.
Yeah, thank you. Thanks a lot for having me.
Yeah, it's
I
great.
also very much enjoyed.
No, hopefully we can get it. We get a chance to chat every once in a while, but looking forward to
Yes.
more conversations and
Yes.
more work that
Of
helps,
course.
clarify and open up both on where the gaps are and coming up with, industry relevant, practical, useful, scalable solutions to many of these questions, and very actively working on many of these questions. So really, really enjoy our conversation today. Thank you so much for the time. Maybe just to end off once again, on the virtue side, I want to thank folks for listening. I will mention briefly again that Virtue AI actively does work around many of what we talked, a lot of what we talked around about today. So red teaming on the attack side, discovering vulnerabilities combined with guardrails on defenses, one of the topics we talked about. We didn't get a chance to talk about multimodal, but I think some of these questions around how multimodal changes some of the attack surfaces. We didn't talk much about systems, but I think fascinating questions there. We invest a lot on making these fast and scalable so that they're not the bottleneck in deployments in real-time systems. And then we talked a bit about agents. And so very happy to follow up with folks that may have questions, virtuei.com. I'm sure people can find you on maybe LinkedIn and other places. But very, very happy to be able to have this conversation. Just want to, pause for half a second if there's anything else that you wanted to say before we end up.
Yeah, again, thanks for having me. I think this is a fascinating area. I think this is one of those areas that I feel like people with algorithmic background can make a huge difference.
Indeed.
And so I welcome everyone who wants to join this community, and hopefully we are going to actually for we talked about the ICML, so the videos are going to be released soon, and we are actually writing a simple tutorial,
Great.
code book, and those kind of things that people just play around and see how they work, and maybe we will have many more friends to talk
That's
to.
awesome. That's great. Great initiative. Looking forward to reading that.
Yes.
Excellent. Well, thank everyone for joining the webinar today. Looking forward to following up and for the conversation. Thanks again, Amin. Really appreciate your time this morning. It was an excellent conversation. Thanks, everyone. Take care.
Bye.
Bye.